how can ChatGPT uh, kind of probe us into understanding cognitive science, specifically in the way that you framed it with the Turing test, or as
I
others
haven't
might know it,
talked
the
about the
imitation
Turing.
game? Yeah.
I haven't, no, I haven't talked about the Turing test. Do you want to first ask me what that is before we talk about it?
Sure, sure. What is the Turing test as you have defined it?
It's not an imitation game.
Right.
Turing, when he defined it, called it the imitation game, but he didn't mean it. You have to believe me, he didn't mean it. He meant what we eventually take to mean by reverse engineering, to figure out how it is that the brain can produce all of the things we can do, including talk. And the test was going to be that once you've got it talking, able to, you give it the ability to talk like we can, to the point where we can't even tell it apart from a person, uh, it's past what we called in class T2, the verbal version of the Turing test. But there was something missing there. And it's not Turing when he decided that, when he proposed that test, it's not Turing who missed it. It's all these people who are missing it now. And when I wrote that article about the symbol grounding problem, it was it got cited an awful lot. It's the most cited article, but I'm not looking at the citations anymore because they all get it wrong. It's really disheartening to hear how wrong they get it right to today. And it's up in the air again with ChatGPT, and people are getting it wrong again. Not all of them. There's some people who are finally getting it. The key word was to ground it. It's got to be sensory motor. You can't do sensory motor um, grounding with a bag of words and a bunch of computer algorithms. You
Mm-hmm.
need to have a robot. A robot is not a computer.
Right.
A robot has sensors and effectors, which are not computation. They're physical devices. And we are robots of a special kind. We're alive and we're sentient. And the reason I don't eat animals is because I don't eat sentient things, because we don't need to. So we are alive and we're sentient, but we're still mechanisms of some sort. So let's call it, frankly, we're machines. Turing was arguing that a machine could do everything we could do. He he I don't, unless you want to get into computation, I won't. But
Go for it.
you want to? Okay. Well, in the original paper, when he suggested the so-called imitation game, which is really just reverse engineering, he was talking in the same breath about two separate things. One of them is what the Turing test is about, which is have I built a device that is capable of doing everything a human being, a normal human being, an average human being can do, not just talk. The assumption is if it says apples are red, it means what it says, and it can tell and it can pick and it can recognize an apple. It can not only describe an apple. ChatGPT can say apples are red and can tell you what red is and what apples are, but those are just words. Can it actually connect to the referent of the word apple and the fruit and so on? So where was I going? The Turing test was about that, but Turing is famous for many things, and another thing he's famous for is the Church Turing uh, conjecture, which is that what mathematicians do when they're doing mathematics is computation, and the computation is just symbol manipulation, which is what a Turing machine does. It takes symbols like X and Y and 2 and 7, etc., and it manipulates them according to a recipe, a formula, uh, to come up with a response, an answer. And the weak church Turing thesis is that that's what mathematicians are doing when they're computing. They're manipulating symbols according to a rule for what to do with what symbol. Let's call them squiggles and squaggles. Uh, a simple version of what computation does is if you get a squiggle, put it down and pull a squaggle. Okay, that's just manipulating symbols, right? And that's what mathematicians are doing when they're doing mathematics. But there's a stronger version of that thesis called the strong church Turing thesis, which says not only is computation anything and everything a mathematician can do and prove, but it also can this is imitation, simulation, or it can simulate or model anything in the world. That means apples, not just words about apples, but it can also simulate apples and it can simulate ice cubes. I'll use ice cube for a good example. You can do a computer simulation of an ice cube. What do I mean by a computer model or a computer simulation? By symbol manipulation alone, if you put in the right recipe, which is an algorithm, which captures just with squiggles and squaggles all of the relevant features of apples and interactions with apples, then you have a model of an apple. And the model of an apple is so good that in principle you can feed it into a virtual reality machine, virtual reality machine, which controls your goggles and your gloves. And with the ice cube, for example, you can say, look, do you see that ice cube on the table? And there's an ice cube on the table, and you can reach forward and you can pick up the ice cube and you can hold it and you can see it melting in your hands. If the virtual reality is really good and it can do, and the gloves have temperature sensors, it can make it feel as if your hand is getting colder and colder as the ice cube melts. But that's all an illusion. To see it's an illusion, you just have to take off the gloves and the goggles and you see nothing there. And in the other room, all you have is a computer that's doing squiggling and squaggling. So the strong church Turing thesis is that computation is so powerful that it can simulate just about anything. And it's not just for fooling you in virtual reality. You can simulate things or model, because it's the same thing to model. You're reading these days all the time when we're talking about COVID, for example. We're talking about according to the current COVID model, which is undetermined, it's not perfect. We predict the following for the following reasons, and if the model is right, it will make the right predictions tomorrow, right? So, and if you build, for example, you have a rocket, the example I used in your class was, if you have a rocket that can do certain things at a certain speed under certain conditions, but if you get into certain kinds of atmosphere, it starts wobbling, okay? And it needs to have that corrected. One way you could do it is to keep on building more and more rockets and trying them, but that's expensive and it could take forever. Or you can model the rocket to the best of your ability and also simulate the conditions that cause the wobbling and see what you have to do to the rocket model to make it stop wobbling. And once you've figured out in the model what to do, then you can build a real rocket using those principles. And that's how modeling, computational modeling is being used these days in everywhere, in physics, in biochemistry, in medicine, and everything, okay? And that's the strong church Turing thesis. The Turing test is about whatever it takes to get a robot to be able to do what you and I are doing now, approximately, indistinguishably from you or me. Not just to talk like us, like ChatGPT, but to connect what's the saying? Put your money behind you, whatever. Cash in the words by showing that you really know what you're talking about. When you say, right, when you say the rocket wobbles, you should be able to not only say it, but you should be able to recognize the conditions in the world where you have wobbling in the robot, right? For example, visually, and tons of so. I don't. You heard the interview on gradient, so you see how I talk, and you've taken my class. So I don't know what your listeners have followed from what I've said. You're following it because you've had a lot of indoctrination.
It was a very welcome indoctrination for one.